Hola, how are you guys doing? So, I am still exploring the turbo modules and code generation, and I thought it would be fun to do some actual functioning module, something fairly simple, small, that later the community can also use. So I thought about doing a secure storage module, right? There's a bunch already of secure storage modules for React Native, but none that are using the turbo modules because it's so new. So I thought it would be fun to combine these two ideas, the turbo modules and the secure storage, into a single package. Also because then I can not only show you turbo module, but maybe I can show you a little bit of the native APIs. So I thought this would be good. So I'm going to start by doing a shout out to Alon. So as I was exploring the turbo modules, he reached out to me and he told me that they already had some turbo module package that was going to be published really soon. So yesterday he actually published it. He made it public. He shared it with me. It's a really cool template for turbo modules, right? So it's really minimal. There's only the stuff that you need, and it's basically you can just clone it and start modifying it to run your turbo module. Now, before we start, there are a couple of things I would like to mention. First, you will need React Native 68 plus to make this work because turbo modules are not, well, maybe somebody will figure it out, I'm sure, to run a module both in turbo modules and in the old bridge. But for now, I will just stay on 68 and just aim for turbo modules. There are a couple of other points, as mentioned before. Codegen right now, it's only generating the bridge or the bridging code and glue code for Objective-C and Java. There is no generation for pure C++. So I'm sure at some point that might be added. But for now, if you want to write pure C++, then you kind of need to do this bridging or trampolining between your JavaScript, Objective-C, native, or JavaScript, Java, C++. So for now, we're just going to stick to Objective-C and Java, which for the APIs that we are interested about, which are the Keychain and the Keystore API, we need to anyways. There is no way to access them. There is no way to access them from C++. One other point that I would like to mention is you need to write Objective-C. I would kindly ask everybody who keeps asking me this, no, you cannot write Swift, you cannot write Rust, right? So this has nothing to do with React Native, with the JSI. If you find a way of calling a Rust method from C++, then you can do it. If you find a way of calling a C++ method from Swift, then you can do it. It's not worth it, really. It's just too much work. Just learn a little bit of Objective-C or a little bit of Java. It's just easier. Okay, so unfortunately, I already tried to stream this and it did. The stream went down halfway. So I'm going to be fairly fast with some of these steps. I'm just going to show you and then jump between commits. This will also be published in GitHub repo. So you should be able to check the code out for yourself. So basically, I just start by cloning this repository. I already have a fork, but I just clone it and I have it already here open on VS Code. And from there, there's just a bunch of stuff that I'm going to take care of, just renaming the package, right? So first, on the, let's go by parts. On the README, there's a bunch of stuff which I don't need. And I'm just going to call this React Native Turbo Secure Storage. Just Turbo Secure Storage, and I don't need the React Native prefix. And then I'm going to go modifying the package name and a bunch of stuff. So first, what I'm going to do is I'm going to go into the pod file of the example. I'm just going to disable Flipper just because it makes compilation a little bit faster. Then the other stuff that I need to change is on, give me 1 second, on my package.json of the root directory. I of course need to rename everything that is called React Native Turbo Starter with my own package name, which will be Turbo Secure Storage. Then, of course, what I want to change is the some of this pod configuration. So turbo secure storage pod spec. Here the same turbo starter, turbo secure storage. Of course I need to change these GitHub addresses. OSP Franco, and of course it's OSP Franco at protonmail.com, etc. Here on the package.json, I also want to change the name of my generated classes, right? So again, this is going to be turbo secure storage. This is going to be the name of my generated module for my codegen. And so on and so forth. So, right, so you kind of get the idea of what I'm doing. This very first step, I'm just going to go ahead and start renaming a bunch of classes and so on. So I'm going to skip forward a little bit. Again, you will be able to see this in the commits. It's not very interesting. This is just me renaming stuff. So I have gone ahead and on the iOS folder, I have also renamed this these two files. I mean, of course I could change this Xcode project stuff, but it's just renaming. And inside of here, I just kind of replaced the content with the new name of the generated spec, just to let you know. And then here on the source folder, I have also changed the native turbo secure storage file, right? So I changed the name as well. That's important. That gets picked up. And here as well, this name also needs to change, and so on and so forth. Just to give you some pointers, just to make sure that you're not forgetting anything. But basically here on the original repository, you have some examples of the spec, of the TypeScript spec that will be used to auto-generate the code. So I basically got rid of the contents of that, and I just created one method which will be used to set the item. It takes a key, it takes a value, and then it returns this error, well, not the error object, but it returns a complex response object, right? That could have an error inside of it. This is a very good pattern for error handling. Instead of throwing errors, you want to return an error as part of your response, because then it's a lot easier to read. I mean, you have to handle this error somehow, and it's just part of the control flow. Whereas with throwing errors, it's fairly invisible, right? Like you don't know if it's going to throw or not. But by making the error explicit, everything works a little bit nicer, in my opinion. So once I have my spec here and I have renamed everything properly, I should be able to go and do yarn bootstrap. Bootstrap. And what this is going to do is going to take my spec, and it's auto going to generate all the files. So I have the project here on Xcode, and here you can see if you go into pods and then development pods, and you should have here turbo secure storage. And inside of here, this imports the RCT bridge module. That's fine. I just renamed this class. And in here, I need to import from turbo secure storage, which is the generated class by codegen. I need to make sure I'm using those classes here as well. When I implement the get turbo module, I need to make sure that I'm implementing the spec JSI generated class. So once that's done, there's one very nice feature of having codegen, which is if I don't properly implement the spec that I have created, Xcode can actually tell me, or C++ actually tries to match the spec, and it tells me something is missing, you haven't implemented the proper API or the proper interface, so you can fix, and it auto generates the stop for you. So basically I just implemented a dummy method for now, and you can see it matches my spec, and I should be able to run this, I think. Okay, so the app has compiled. I have it, it runs here. So basically I have just modified the app.tsx, so it just contains one button that calls my method, right? So if I click on it, it looks like nothing happens, but here on the output you can see my output. Okay, so that's great. That kind of takes care of all the turbo module and codegen parts. I know I did it fast, but you can take a look at the previous video to go over it. So now we can go over the actual API implementation of the keychain. So the keychain, I'm just going to do iOS on this video. The keychain is a very old API from the next days. It's implemented on C, so you can actually directly call it, import it in your Objective-C code. And it's a little bit funky, it's a little bit wonky. You need to create a dictionary with a bunch of keys and a bunch of values. And actually, it wasn't designed to store any piece of data, right? When it was created, it was basically thought about, you might want to save some password, might want to save some certificate, etc., etc. So we're going to kind of abuse the API a little bit, and we're going to save a password, basically. And that's going to act as a key value storage, right? But it's secure, so you're not able to interact outside of your application with it. So what I'm going to do is just I'm going to copy some codes just a little bit, just to make this a little bit faster. And I'm going to include two frameworks first. The first one is, this is not working, okay, Xcode is slow. The security framework, which is basically Keychain, and the memory, which contains some extra classes that we're going to need. So on my set item method, I am going to first, let me just copy some dictionary code. So first I'm just going to allocate a mutable dictionary. Like I said, codegen right now is only working for Objective-C and Java. So this is possible to do on C++ alone. You need to do some marshalling between the types, of course. I mean, C++ has no dictionary, so you need to create vectors and then initialize some of the classes, but doesn't really matter. So for now, I'll just create a mutable dictionary, and inside of it, I need to set some classes. So the first class that I need to set, or the first value that I need to set, is this class generic password. So like I said, it's a very old API, so we're just going to trick it to think that our data is a password. And this is, we need to set it for the keysec class and the keysec class generic password. Then we have our identifier, which is basically the key that we take from our method, and then we just encode it. We just get the binary representation of a string. And then we need to set some other values. So of course my identifier goes into the attribute generic, and also the account. So this kind of acts as the key to access the data. Then we also set the sec attribute service. So this is to tell the OS, either iOS or macOS, which service has access to this key, right? So you can make this on OS level, on application level. For us, we're using the bundle identifier. So we're basically telling this secure piece of this key or this value can only be accessed by this bundle identifier. Then finally, we take our value on our data. We get, once again, the UTF byte representation of it, and we add it to the dictionary with the sec value data key. Finally comes the time to actually write the keychain to the keychain. So we use this function sec item add. We pass our query dictionary. You don't need to worry about this parameter for now. And this returns a status item. So this OS status, this is actually a far more complex enum, which is used on a different bunch of operations which are more low level than usual, right? So you have OS error, an error code, status, and I can't find the time, but it doesn't matter, right? So it's just an enum for very low level OS operations. So once we have that response, what we can basically do is we just compare. We can compare our response of dictionary, or the status that we get. Sorry, our status that we get, if it's different from an error, or if it's a success code. Then basically we're not able to save the value for whatever reason, right? So one of the point right now, which I'm not really sure how to do, is how to throw JavaScript errors from these methods, right? We're going to take a look into the code inside of some of this marshalling code, and there doesn't seem to be any way to do it right now. For now, also the code is somewhat messy, but I don't care, right? I'm just trying to show you how to bridge this native functionality. So if we get an error, basically I'm just going to return a dictionary with an error field and a string for now. If we don't get any error, then we just return an empty dictionary, and we can just compile this, and hopefully it should work. Nice, right? So it doesn't crash, it doesn't throw any error. It's basically just working. So here I can also go something like const error just to make sure. And if I have an error, I just basically say console error could not save item. And if I don't get any error, saved item. Oh yeah, sorry. I need to return this, and let's try to run this again. Could not save item. Let's try it like this. Okay, so I was just trying to override the key that I said before. So like I said, this is the problem with the very old APIs. They're not very safe. You need to make sure that no data is in there before you can overwrite it. Just API specific stuff. But we basically now have securely store a piece of data. So the next thing that we want to do is securely retrieve this piece of data, right? So I'm going to go back into my spec, my TypeScript spec, and I'm just going to add another method that says getItem. It takes a string and is going to return, again, something similar, an error. I mean, I'm just going to change this type. Of course, you might at some point want to return more complex objects, but for now. And let's just call it data string. Okay, so I'm going to run yarn bootstrap again. So this will it will regenerate the codegen classes, and then after this is done, let's just wait for a little bit. If I go back into Xcode, yes, read from disk. If I just give it a second to think about this, I should get this warning, right, which says it doesn't confirm to the protocol. This is really nice, right? So I can just tell it, yes, fix it. And it should insert my missing method for me. This is really cool. This is really nice. So basically, I'm just going to, once again, copy this. Give me 1 second. I'm just going to copy the implementation of this because it's not super interesting to type everything by hand. And it's something very similar. Again, we need to create a dictionary with some of the keys, with the same keys that we have created before, with the exception of the data. And there are 2 extra keys, which is one, the match limit. We set it to limit 1. We just say if you find more elements with this key, just return the first one that you find. And this sec return data, which tells the keychain not only read it, because you can just query the keychain and tell it, if this value exists or not, but actually return some data to me. So then we have this different API, which is sec item copy matching. So again, one of these very old APIs, they're not super straightforward on their usage. So basically to read, you're just copying the data, right? You read it and you immediately copy it to some data reference. So that's why we have this CF data ref, which at the beginning we set for nil. And then again, it's similar check. I mean, this one is inverted just because I copied and pasted from the internet. But if the status is no error, then basically it means we have successfully read it from secure storage, and we can basically just marshal it back into our response, right? So we create a dictionary. I just put my return string in there. So, of course, converting from byte data back to a string, etc., etc. And I just return that dictionary. If no value has been found, I just return a different object with the error key. So I'm just going to save that, compile, and on my JavaScript application, again, I am just going to copy some button implementation. So this is very, very simple code, right? So I'm just calling my module. I'm just going to replace some of this stuff, console, warn, and then I just return, and I have my data in here. Good. So once this compiles, we will run our app. Great, so now I can just do get item, and you can see we get the value from secure storage, right? Really cool. Now the last thing that I'm going to do is I'm going to add yet another method, which will be the delete item. Again, something similar. You might return an error if was not able to delete. I regenerate my classes. I am going to once again just copy my implementation. Yes, read from disk, and I just implement my method. It takes a key. Again, this map of attributes. And then the method that I'm trying to call is the securely item delete, right? And again, I just check the status of the operation. If it was not successful, then I return an object. If not, I return an empty object. The code is a little bit messy. Of course, this can be done a lot nicer, but I'm just trying to show you how to use this API. Great, so I compile the app. I'm going to go once again back into my JavaScript, and I'm going to add yet another button. This time for deleting the data. Good. This one is failing because I'm missing this. Okay. So if I go back into my simulator, I'm just going to wait for a little bit to compile. Great, so now I have my 3 buttons. I try to delete it, I get my item deleted. If I try to read it, there's nothing in there. I'm going to set it again. This one's failing for some reason. Oh, yeah, let's try this. I'm going to delete it. Okay, now it's saved, now it's retrieved, and so on and so forth. So that's how you implement secure storage on iOS. This is where I'm going to end this video. On the next video, I'm going to take a look into Android with use, well, we will use the KeyStore API, which is a completely different API, it's a completely different model. I like the iOS version better, but you know, in any case, I hope you learned something. You can see it's really easy to create your own modules now. These functions, just in case it's not completely clear, they are JSI functions. It's just that they get called internally. So these are Objective-C functions, but then internally they get wrapped into JSI functions, right? So you do get the speed bump. Oh yeah, it would be actually really good to... There's one thing I wanted to show you, which is kind of a little bit the internals of how these methods are being called. So I'm just going to command click on this native turbo security storage spec JSI class, which is the auto-generated class that we just implement. And here, this is my generated header. And then I'm just going to go into this one. And here you can see this is kind of the internal glue code between your or the code that we have written on Objective-C and kind of the internals of the turbo module, right? So it creates basically a map of, you know, the functions that we have. And then internally, they are JSI functions, right? So Facebook JSI value, blah, blah, blah. It just takes a bunch of parameters, and then it just tries to call the function based on the map that has been created for you. So if you take a look into this Objective-C, invoke Objective-C method, that you can see there's a bunch of interesting stuff in here. Basically, it just makes sure that whatever you're returning, it will be able to be marshaled into the JSI types, right? So for example, if you have a return type of the promise kind, it's going to inject the reject blocks and the resolve blocks into it, which is really nice. And here, for example, you have at the end of the day this this is the performance logger. What I want is perform method invocation. So on this one, again, just a bunch of glue code. They are measuring some performance. But here, for example, here are two very interesting points. Here's one to do. We should guard this with a try catch. So for example, what happens if your native code crashes somehow, right? Or tries to access some, just somehow throws an error. Right now, there doesn't seem to be any error handling. For me, this is not a to-do. This needs to be there so that your native errors don't just pop up all the way to the JavaScript thread and just crash your application. The JavaScript code should be able to do a try catch on these exceptions. So I'm not really sure how that's supposed to work, but this is really early work, so I'm sure at some point it will be clearer. But here's a very interesting part. So for example, you have the return type. So depending on how you have declared your functions, whatever you return from Objective-C or Java will be mapped into JSI compatible values, right? So this is the interesting part, which is not completely clear. If you just take a look into the documentation, you might think, okay, this is just using the old methods and the old bridge, which is not necessarily true. There is marshalling from the native types, Objective-C types into JSI conversion or JSI values. So this is really, really cool stuff. I just wanted to show you this just to get a better understanding of how things are working. This is all implemented on the turbo module specification. But that's it. On the next video, we will probably explore Android. Yeah, enjoy. Remember, I'm available for React Native consulting, and have a good day.